So our goal today is that we sort of want to bring everything full circle here, right? We've been talking about all these different things that we can do. We want to put this last sort of piece to it, which is finishing doing some work with writing equations of lines. We've already been doing it. Okay, we're going to sort of just bring everything that we've been talking about together. Okay, so we already know several ways to write equations of lines. So I'm sort of going to go through and break these down into some categories. One, we already know that we can write the equation of the line if we are given or we can find the slope and the y-intercept. Right? And we know at this point that slope is represented with the letter M and that the y-intercept is represented with the letter B. So it might use the word slope or it might have the letter M, or we might have to find it from a graph. Okay, but we know that we can write the equation of a line if we are able to find or we're given M and B. And if we're doing that, if we're given that, we're just going to plug into y equals mx plus b form. Right, and we looked at problems like this last week. So for example, if something said m equals 3 and b equals -5, we could then plug in and say, okay, the equation is y equals 3x minus 5. Right, if we were given a graph, we might have to find the y-intercept and count rise over run to find the slope, but same idea, we would still then just plug into y equals mx plus b. Okay, the second thing that we know how to do is we know how to write the equation of the line if we are given or we can find a slope and a point. Okay, it makes sense that if we're given a slope and a point, we would be plugging into point slope form, right? So that's our y minus y sub 1 equals m times x minus x sub 1. And remember, you can use your notes. So these formulas you'll have as long as you wrote them in your notes. Okay. And we said, right, if we were looking at a graph, we might have to identify them. Okay, so we might have to pull it out. But if we have m equals 1/2, and we have the point 2, 7, or we found them from a graph or whatever, right, we could say y minus, right, this was our x sub 1 and our y sub 1, so y minus 7 equals 1/2 times x minus 2. Now, this third option, we haven't really come full circle to talk about, but it's kind of an oddball. So I kind of put this in its own category, that we can write the equation of a line if we are given undefined slope. And the reason why I put this as its own category is I can't plug undefined in for m, right? So it doesn't fit into either of these as m. But we know at this point that undefined slope, right? We know undefined slope is a vertical line. Okay, and hopefully at this point we know that a vertical line is x equals, and then we'll fill that in with whatever number we're given. Okay, so if we have something like m equals undefined, now we can't have a y-intercept, right, because it doesn't cross the y-axis, but maybe an x-intercept of 4, right? That equation would be x equals 4. Okay, if we were given something that said m is undefined and it passes through the point -2, 7, we would say x equals, and in this case our x value is -2. So x equals -2 would be our equation. Now we also talked about on Friday of last week how to switch between all of these forms. This is sort of going to come all together here. Okay, so let's say I want to write the equation of a line if I'm given a slope of 1/2, and I know that it passes through the point -4, 10. Okay, so we're given a point and we're given a slope. So we're going to plug into point slope form. So we know how to do that. Y minus 10, right? My x sub 1 and my y sub 1 equals my m, which is 1/2, times x minus my x coordinate, which is -4. And just like we talked about last week, we won't leave this as two negatives, right? We'll turn that into a positive. Now, we discussed last week that point slope form is kind of a pain because there are other points on the graph, and so oftentimes we can represent the same equation in lots of different forms. And we want them all to look the same. We're just happier when it looks the same. So just like we wouldn't leave something of 4/8 as 4/8, we would reduce it to 1/2 so that we all have the same answer. We are always going to want to solve point slope form for y. Okay, so whether you read it in the directions or not, it doesn't matter if it says solve for y. If it asks you to write the equation of the line, you need to solve it for y. Okay, and this was Friday, so we'll distribute, which says 1/2 x plus 2, right? And then we'll undo subtraction with addition, and we'll have y equals 1/2 x plus 12. And this is the answer that we would want to use as our final answer, because then no matter what, our answer will look exactly the same as our neighbor. Okay, and it becomes even more important because let's say we want to write the equation of the line. If we are given -6, 5 and -4, 6. Okay, so if we want to write the equation of the line, we're a little bit questionable here on this one. Okay, I don't know, questionable, right? We have to do a little bit more work. Maybe that's the right way, right? And there's lots of different ways that we could find it, right? We don't fit into our category straightforward. We don't have a slope and a y-intercept. We don't have a slope and a point. Okay, but we do have 2 points, which gives us enough information to find the slope. Now, you could find the slope by plotting this on the coordinate plane and counting rise over run. Most of my students are going to prefer to just mathematically find it with the formula, right? That says y2 minus y1 over x2 minus x1. And so we'll say 6 minus 5 over -4 minus -6. 6 minus 5 gives us 1. All right, this is going to give us a 2. So we get a slope of 1/2. So now we definitely have a point and a slope. We actually have 2 points and a slope. So you can decide to pick whichever 2 you want, or whichever of these 2 you want. You have to use the slope, and you can decide. Smaller numbers, fewer negatives, maybe it has your lucky number in it. Maybe you just pick whichever one is first every time. It doesn't matter, you're just gonna pick one. And then we can do what we did up here and plug into point slope form, right? So point slope form says this. So I'm doing y minus, my y coordinate is 6, equals m, which is 1/2, times x minus my x coordinate, which is -4. 2 negatives here are going to make a positive. Now, the thing is that if someone picked this other point, their equation would look different. So again, even though the directions might not say it, we are going to solve for y so that we get the same thing. So we'll distribute. And then we will add. And we'll get y equals 1/2 x plus 8. Okay. Let's say we're given a table. I don't know, we could have tons of numbers in it here. I'm just going to do a few. Okay, and we need to write the equation of the line when we're given information in a table. Okay, good news. A table really is no different than being given a bunch of ordered pairs. Okay, you could decide to plot those ordered pairs if you wanted to, right? You could decide I want to make a coordinate plane and plot all those points on there if that's what you wanted to do. You could decide to find slope the way that we go here. Okay, and say that this is subtracting 3 and adding 1. You could even decide to find the slope by naming 2 points. It doesn't matter which 2 you pick. You just need to pick 2 of them from the table. I always prefer to pick the smaller numbers, but there's nothing wrong if you pick something larger. So if I do -12 minus -9 over 4 minus 3, I get that -3 over 1, which is the same thing I would have got here. So now I know that my slope is -3. And then we're going to pick a point. Okay, this time we actually have 1, 2, 3 points. We can pick any of them. So let's say I pick the ordered pair 3, -9. Now I can go back and do the exact same process. Plug into point slope form. Y minus my y coordinate is -9 equals -3 times x minus my x coordinate, which is 3. Again, we're always going to solve for y. So I'm going to distribute. A negative times a negative is a positive. Oop, over here, right, these 2 negatives make a positive. And then I'm going to subtract. And we'll get y equals -3x plus 0. You could write the plus 0. You don't have to. Okay, so at this point, we should feel like we can work successfully between a ton of different forms, right? We should be able to work between whether we're given a graph, whether we're given a table, whether we're giving ordered pairs. We should be able to plug things into some of these different forms. We should be able to solve, right? Go from point slope form to slope intercept form. If we really had to, right, we could take this and put it in standard form because we talked about that on Friday. Okay, so we've sort of made this full loop here. If we were given this, we could graph it. That now we can go in between all of the different forms and still be representing the same function or linear function, but just using whatever might be best in a specific situation. We'll start talking about what might be best in a specific situation as we move forward.